My dad is blind in his left eye. He only has tunnel vision in the other. He has an eye disease called glaucoma, which causes a gradual loss of peripheral vision, often going unnoticed for years. Too often, it ends in complete, irreversible blindness. But my dad isn't the only one with this disease. About 1 out of every 30 people you know will develop glaucoma in their lifetime, and my research aims to find a way to treat it. So what causes glaucoma? We don't completely understand what causes glaucoma, but most patients have elevated pressure in their eyes. This pressure comes from the constant production and outflow of a fluid that bathes the inside of your eye with nutrients and washes away waste. The fluid is produced behind your iris, the color part of your eye, flows out through the pupil, and exits around the edge of the iris. There, a group of cells work like the toll booths behind me to regulate the rate of fluid leaving the eye. They do this by contracting, removing debris, and controlling the density of the meshwork they're embedded in. This creates a steady flow of fluid traffic, just like in the image. And just like a certain amount of traffic is good, it means business is going as usual, a certain amount of eye pressure is good. It means the eyes are healthy and being kept in their proper shape. But if the toll booth cells don't allow enough fluid to leave the eye, the pressure builds up like a traffic jam, and the pressure can increase too much and cause damage to the neurons that send light signals to the brain. And this causes blindness. So how do we lower eye pressure? Several studies have shown that males have a higher risk of developing glaucoma than females until the age of menopause. After the reduction of female sex hormones during menopause, females begin to have higher glaucoma risk. And both glaucoma risk and eye pressure are lower in menopausal women using hormone replacement therapy than those who do not. This suggests that female sex hormones such as estrogen protect against glaucoma by lowering eye pressure. I believe estrogen does this by acting as a fast pass, improving toll booth cell function and allowing fluid to move through the meshwork at a steadier rate. So how am I testing this? I've already identified the presence of estrogen in human eye fluid, and I've also confirmed the expression of estrogen receptor in toll booth tissue taken from human eye donors. Now I'm using a mouse that lacks estrogen receptor, preventing estrogen from sending messages. I measure the pressure of the mice without the receptor and compare it to that of normal mice. My results suggest that loss of estrogen receptor makes eye pressure higher. My next step will be to see if the function of glaucoma toll booth cells can be restored by estrogen treatment. If my work is successful, new therapies such as estrogen eye drops could be developed to lower eye pressure and stop vision loss. My dad has already completely lost vision in his left eye, and much of it in his right. That vision will never be restored. But maybe, one day, my research can stop glaucoma from stealing the sight of others like him.